Welcome to this Teaspoon AI video on the Leetcode candy problem number 135. In this video, we will be exploring a solution with a time complexity of big O of n, which means it will execute in linear time relative to the size of the input array. Additionally, we'll be adhering to a space complexity of big O of 1, which signifies that our solution will use a constant amount of additional space regardless of the input size. First, let's take a look at the simple case where the ratings array is monotonically increasing. In this example, we have a 4-element ratings array, so we'll initialize an array for candies to also be 4 elements. Note that this candy array is shown only for illustrative purposes and will not be used in the code solution because we wish to have a constant space solution. We know from the problem statement that the candies array will always contain at least one candy, so we initialize the 0th element to hold one candy. We create a variable named up to store the current number of consecutive elements where the difference between the current element and the previous element is positive. In other words, we're keeping track of the run length of increasing elements. Now, observe that the nth element of the candies array can be calculated using the formula up plus 1. Let's iterate through the ratings array to demonstrate this formula. We can transform this sketch and formula into code. Note that in this code, the variable named candies stores the total number of candies rather than keeping track of how many candies each individual child receives. The number of candies is incremented by the upward run length plus 1 on every iteration. Our formula works for the simple case of increasing elements. What if we extend the ratings array to have decreasing elements as well? We create a new variable named down to store the consecutive number of decreasing elements. For the downward case, we also use a new formula that calculates the nth candy to be equivalent to down. Once again, we'll iterate through the ratings array. I've ended the iteration one element early for reasons explained later. For now, observe that when flipped horizontally, the last 3 elements in the candy array accurately tracks the number of candies that should be given to each child. So while this formula doesn't tell us how many candies each child should receive, it still accurately tallies the total number of candies given. Let's incorporate the downward case into the previous code solution by inserting the new down variable and condition, making sure to reset the run length variables when the gradient changes direction. Finally, the last element leaves us with the most difficult case. Notice that if we continue with the current formula for this element, the constraint introduced in the problem statement would be violated. This is because the 3rd child would receive the same number of candies as the 4th child, despite having a higher rating. What can be done? The trick is to keep track of the last max height. In this example, the 3rd child reaches the max height of 4. If the down run length is lower than or equal to the max height, we increment candies by 1 additional element. This is visualized here as giving an extra candy to the 3rd child, such that they now have 5 candies. Let's incorporate this special case into our code. Notice the new variable named lastMax and how it is used in the upward and downward cases. Finally, note that there is one case we didn't analyze, which is the case where the current rating element is equal to the previous rating element. This case has the effect of resetting the problem. We leave it as an exercise to the viewer to think about why this is. Thanks for watching.